Okay, so I'm going to go through paper 1H, which I handed out not too long ago. Let's get straight into it. So question 1, we have a fractions question, division. First things first, we need to change these so that they're top heavy. So 4 2/3, 4 times 3 is 12. Add the 2, it's going to be 14 over 3, divided by 1 times 9, 9, add the 1, 10 over 9. It's important you show all the steps in this. So I'm thinking, well, this is worth 3 marks. What else do I need to show? Well, I need to show the process of dividing fractions, which is the first fraction stays the same, flip the second fraction to 9 over 10, and the division becomes a multiplication. Now at this stage you can either multiply it across and simplify it, which I'll do, but you could cross cancel here as well. So 14 times 9 is going to be, let's see, 126 over 3 times 10, 30. Now it's not okay for me to go straight to 4 1/5 from here, so let's simplify this first. If I divide top and bottom by 6, then I'll have 21 on the top over 5, and this equals 4 1/5. Okay. Question 2. Jelena left her home at 10 o'clock. This first part is asking us to work out which is at which point in her journey is she traveling fastest. So, and to give a reason for it. So the key thing here is to look at gradients. So over here for 1 hour, in fact I'll just highlight it. So for the first part of the journey, in 1 hour we're traveling 15 kilometers. So our gradient here is, I guess, 15 over 1. Whereas in our second part, we are traveling in 3/4 of an hour. We are traveling 9 kilometers. So our gradient for the second part is 9 over 0.75. And if we work that out, that comes to 12. So gradient is larger before she stopped. Therefore, let's answer the question. She is traveling faster before she stopped. Now, question 2b is saying she stayed in the park for 45 minutes, so that's going to result in a flat line for 45 minutes, which is 3 squares. Okay, something like that. Let me just get rid of this a little bit. Okay. And then she cycled home without stopping at a constant speed of 16 kilometers per hour from the park back to her home. So if she's traveling at 16 kilometers per hour, for every 1 hour, so for every 4 squares she goes across, she's going to go 16 down. So that means for every 1 she goes across, she's going to go 4 down. So let's just draw this line in. Every 1 she goes across, 4 down, 1 across, 1, 2, 3, 4 down, 1 across, 1, 2, 3, 4 down, 1 across, 1, 2, 3, 4 down, and finally 1 across, 1, 2, 3, 4 down, and we should end up, whoops, perfectly. I haven't quite got perfectly there, but I'll have another go at 2:15. Okay, so something like that. Okay. Work out Jelena's average cycling speed in kilometers per hour for the complete journey to the park and back. Do not include the times when she was not cycling in your calculation. So first off, we need to work out how far she's gone. Well, she's travelled 24 kilometers there, and similarly 24 kilometers back. Okay, and we're working out average speed in kilometers per hour. Okay, so she has travelled 48 kilometers. And now we need to have a look at how long it's taken her with all the stops. So, or without the stops, I should say. So we've got 1 hour here. We have 3/4 of an hour, 0.75 here. And let's just work this out if I drag this down. Okay, we've got 1.5 hours later on. So altogether, we are going to have 2.5, 3.25 hours, or 3 hours and 15 minutes. But if I do this calculation, 48 divided by 3.25 on my calculator, I get 14.76923, and it's recurring between 7, 6, 9, 2, 3 and 0, and we're asked to give our answer to 1 dp, so this is going to be 14.8 to 1 dp. Let's just make sure that's in the answer box. 14.8. Most common mistake on this one is to just work out, or is to sort of focus too much on this word average here and just do the average speed and divide it by 3. Or add all 3 speeds up and divide by 3, but it's a much simpler question than that. How far have they gone? How long has it taken? What's the average speed? Okay, question 3. We're dividing powers, which means taking them away. So this becomes e to the power of 4. When we've got brackets, we need to multiply the powers. So this is y to the power of 16. Expanding brackets, either FOIL or crab claw. Okay, so we've got x squared minus 2x plus 9x minus 18. Always show you're working a little bit rather than jumping straight into x squared plus 7x minus 18, just in case you make a mistake along the way, and factorize fully. So if I look at the numbers first, 4 goes into both of these. The smallest power of your c's is just 1c, and the smallest power of the p's is p squared. So this will go outside the brackets. What do I need to times this by to get 16? 4. What do I need to times c by to get c to the power of 4? C cubed. And I don't need to times p by anything at this stage. In the next part, I need to times by 5 to get 20, and I need to times by a single p to get p cubed. So let's just write this in the answer box. 4c p squared times 4c cubed plus 5p. Next question. Complete the table of values. Now remember, you can use your calculator to do this, which I'm going to do. Go into mode, table mode, and type in x squared, x squared minus 3x minus 1. I want my table to start at -2 and end at 4, and I'm going up in steps of 1. And my table comes out giving me answers of at -2, the value's 9. And then I've got 3, -1 at 0, which checks out with this, which is good. At 1, I get -3. I've got -3 again at 2, which checks out, so I'm gaining confidence in this. Then -1 and 3 again. So if I plot these points on the graph below, -2, 9 is going to be here. -1, 3 is going to be here. Make sure your points are really clear. 0, -1 down here. We should end up with some symmetry. 1, -3, 2, -3, 3, -1, and 4, 3. It's got to be a smooth curve. Oops, and it's got to go through all the points, so I'll try that one again. Okay, going through all the points nice and clearly. The other bit about this is there has to be a little bit of a dip below. So I've got to make sure I show this as I draw this graph out. Okay, and that should get me all the marks. Becky has a biased dice, 6-sided dice. We know the probability's got to add to 1, so already I'm thinking 2x at 0.18 add 2x, add 3x, add 0.26, add x has to equal 1. So this is what I'm thinking as I go forward. Becky's going to throw the dice 200 times, work out an estimate for the number of times the dice will land on an even number. So yes, let's work out this value of x first. I have 2, 4, 7, 8x here. If I add all of these probabilities up, well, there's only 2 there. 0.18 add 0.26 is going to be 0.44. That equals 1. So 8x equals 0.56. And if I divide both sides by 8, x equals 0.7. Oh, sorry, 0.07, I should say. That isn't the answer so far. We're trying to work out an estimate that the dice will land on an even number. So that's either 0.18, 3 times 0.07, so that's 0.21, or 6, 0.07. So let's add all of these probabilities up. 0.18 add 0.21 add 0.07 equals, let's see, 28 add 18 is going to be 46. 0.46, and if we roll it 200 times, we multiply 200 by this probability, 0.46, and that gives us 92. So we estimate that there's going to be 92 times it lands on this value. Okay, question 6. We've got a solid cuboid made of wood, 5 by 8 by 12 centimeters, and it's got a density of 0.7 grams per centimeters cubed. This unit is very important for this question. So work out the mass of the cuboid. We need to use our formula, density equals, and the key is in the units here, grams over centimeters cubed. Okay, we know that the density is 0.7, so I can change this to 0.7 equals grams over. Now, what's the volume of this going to be? Well, the volume of a cuboid is 12 times 8 times 5, which, if I use my calculator, is 40 times 12, 480. So let's put that in here. And therefore, the amount of grams this is going to be is 0.7 times 480, which is 336. Okay, standard form. Right, 5.7 times 10 to the power of 6 as an ordinary number. Now, you can use your calculator for all of these, but I like to draw out loads of zeros and just count the number of jumps. This one's going to jump 6 times, 4, 5, 6. So that's got 5 zeros after the 7. 5, 7, 1, 2, 3, 4, 5. 5.7 million. Right, 0.004 in standard form. Well, this is going to be a number between 1 and 10, which is 4. How many times will the decimal have moved there? 3 times. It's a smaller number, so it's going to be times 10 to the minus 3. Now, for this calculation, there's several ways you can go about doing it. The easiest way is to just type it in on your calculator. If you type it in on your calculator, we end up with 5 million. But if you did want to sort of play around with it a little bit, we can say the top, if I change them so they're both in the same standard form, I'd have 2 times, 2 times 10 to the 4, add 30 times 10 to the 4, over, and I'm going to change the denominator as well, 64. So I've times that by 10, I've got to take away 1 from the power of 10, 10 to the minus 3. And this is going to be 32 times 10 to the power of 4 on the top, divided by 64 times 10 to the minus 3. Okay, so 32 divided by 64 is 0.5 times 10 and then we would subtract the powers. 4 minus minus 3 to the power of 7. So this is 5 times 10 to the power of 6 if we wanted it in standard form, but this is the same as 5 million. Again, as I said, with something like this, you can just type it in on your calculator. Okay. A boat depreciates by 8% per year. So straight away, before I read the rest of the question, I'm making a note that my percentage multiplier is 0.92. Okay, so he bought this in 2016 for $170,000. So that's my starting value. And we want to work out the value of the boat on the 1st of January 2019. So it depreciates every year. So how many times is it going to happen? Well, 2017 will be 1 year. 18 will be 2 years. 19 will be my 3rd year. Okay, so it's happening 3 times. So I can use my compound percentage formula times by 0.92. I can do this calculation 3 times if I want to, or I can just say we're going to times it by this cubed, and my final answer, if I type this out, is 132,376.96. But it asks us for the nearest dollar, so my final answer is going to be 132,377. I think the mark scheme does allow you to put 0.96, but do read the question and be absolutely certain. Okay, question 9. We're looking to work out the area of this shape. It's made from a triangle and a semicircle. So first off, let's have a look at this triangle. It's on its side with a right angle here, 6 and 6. One of those can be your base, one of those can be your height if you think about it on its side like this, 6 and 6. And the area of that's going to be a half times the base, 6 times the height, which is 18. Okay, now to work out the area of this semicircle, first I need to work out the radius. How can I work out the radius? Well, I can work out the diameter by using Pythagoras to work out the hypotenuse of the triangle. So a squared plus b squared equals h squared. I write it this way so I remember it's the hypotenuse on its own. So 6 squared add 6 squared equals h squared. So h squared equals 72, or h equals the square root of 72. And this comes to be around about 8.4, I think. 8.485, blah, 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 blah. Okay, but I don't want this. This is my diameter. I want the radius, so I need to divide this by 2. Which is either 3 root 2 or, if you want to write it as a decimal, 4.24. ... Again, I'm tending to want to use exact values where I can, because rounded values might take me away from the exact answer. So the area of a circle is pi r squared. This is a semicircle, so I need to do pi r squared and then divide that answer by 2. So this is going to be pi times 4.24 squared, or 3 root 2 squared. If you do use the exact value, remember to put it in brackets, otherwise it will just square the root 2 and not the 3 as well. And this gives me, where are we? So 3 root 2, so right, pi times brackets 3 root 2 squared on my calculator is 18 pi. That's a nice number. I need to divide this by 2, remember, because this is the full circle. And you can hopefully see that that's 9 pi if you just divide that by 2. So the total area is going to be 9 pi, which is roughly 28 point, well, it is 28.274333388, blah, 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 blah. add that 18 we had for the triangle earlier, and that comes to 46 point, how accurate did it want? 1 dp, 0.3. Okay, a is 2 to the power of n times 3 times 5 to the m. So 8a is going to be 8 times this. So 8 times 2 to the n times 3 times 5 to the m. Now, the most common mistake I saw here was everyone timesing each of these terms by 8. But this isn't what happens. It's not like your brackets where you've got x times a plus b, and it's multiplying two separate terms. It's like saying x times a b, which would just stay as x times a times b. Though we wouldn't have to multiply everything through. So let me just go back to erasing everything here. So I can think about this as 8 is 2 cubed times 2 to the n times 3 times 5 to the m. Now I can combine these powers, adding the powers together, 2 to the power of 3 plus n times 3 times 5 to the n. So that's going to be my answer. Okay, upper and lower bounds. So straight away, as soon as this says this has been a has been rounded to the nearest integer, I know I need to plus or minus 0.5, half of one, half of the nearest integer. Now, if this has been rounded to the nearest 5, I would be adding plus or minus 2.5 for my upper bound and lower bound. So a is either going to be, I'm either going to use 5.5 or 6.5. And for b, I'll be using 12.5 or 17.5. Now c equals b minus a, and I'm trying to work out the maximum value of c. So this is going to be the largest value, largest, I should choose ub, upper bound, minus the smallest value I can for a. Okay, so this is going to be 17.5 minus 5.5, which is 12. Okay, factorize 2x squared minus 7x plus 6. So straight away I'm thinking 2x squared. So my brackets are going to start off with, the only way to make 2 is 2 times 1. And I've got a minus here, but a plus here. So I'm thinking of two numbers which multiply to 6, but when you add them together, it will be negative. So actually, both of these are going to be negative. It's the only way to multiply to get a plus and add to get a negative. And these numbers are either going to be 6 and 1 or 3 and 2. Now, 6 and 1 isn't going to work out. It will give me a much too big value in the middle when we crab claw it out or foil it out. But if I think 2 times 3 gives me 6, and 2 times, and then 1 times 2, that would actually take me to, so this would give me minus 6, and this would give me minus 2. That's actually still not right, is it? That's minus 8 rather than minus 7. But what happens if I try it the other way around? So if I had 2 over here, then this is going to be 2 times 2 minus 4, and 3 over here minus 3. That now does give me that minus 7. So this is going to factorize to 2x minus 3, x minus 2. Okay, solving b. We have a fraction in this equation, so first things first, let's multiply through by the denominator. So the left-hand side would just become 4m plus 9, get rid of that denominator altogether. My right-hand side would be 7 minus 2m times by 3. Okay, don't forget those brackets. Everything needs to be times by 3, or if you want to do it straight away, 21 minus 6m equals that 4m plus 9. Now I'm going to group all the m's on the same side, so adding 6m would be 10m, and taking away 9 from both sides would be 12. And dividing both sides by 10, m equals 1.2 or 12 over 10, however you want, or 6 over 5 if you want to write it that way. All right, 1.2. Okay, part C. Now, we want to write this in the form of y to the power of b, where b is a fraction. So for this, the fourth root is the same as writing y to the power of a quarter, and writing it over is like saying divided by. So this is divided by y. Now the power here is y to the power of 1. So again, we're using our laws of indices. We would subtract. So a quarter minus 1 is y to the power of minus 3/4. That's going to be my answer. Y to the power of minus 3/4. B is minus 3/4. Okay, question 13. We have a tree diagram question. A team is made by picking a random child from group C and a random child from group D. So C, there are 6 girls and 8 boys, so that is 6 out of a total of 14. And for the boys, there are 8, so 8 out of a possible 14. You could write it as a decimal, but I think in this case it's easier to write it as a fraction. The decimals would go on forever as well. The second part of this tree diagram is out of 10, because there's 3 girls and 7 boys. So 3 out of 10 girls and 7 out of 10 boys. Now at this stage I like to complete this column by multiplying all of these probabilities together, which you don't have to do, but I just like to do it because it gives it that sense of completeness for me. So 42 out of 140, 8 times 3 is 24 out of 140, and 8 times 7 is 56 out of 140. And if you add all of these together, 18, 42, 24, 56, you get 140. So the total is actually 140 over 140. So I'm pretty confident with that working there. Work out the probability that there are 2 boys in the team. Well, that's going to be this root. Now, remember, so it's this 56 over 140. I'm just going to show you the working though. 8 over 14 times 7 over 10 is 56 over 140. Let's see if that simplifies down on my calculator. 56 over 140 equals 2/5. That's a nice number. That gives me confidence. Okay. And part C, after the first team has been picked, a second team is picked. 1 child is picked at random from the children left in group C, and 1 child is picked at random from the children left in group D. So if we've already picked 1 from each of these groups, the new probability of picking a boy is going to be 7 out of 13. 1 fewer boy and 1 fewer person altogether in group C. And similarly, in group D, it's going to be 1 fewer boy, so this will be 6 out of 9. Okay. So the probability of this is going to be 42 out of 13 times 9 out of 117. Now this is not my final answer, because if I'm trying to work out the probability that there are 2 boys in each of the 2 teams, I need this to happen after the first thing has happened. So after we've already picked 2 boys. Now the probability that I pick 2 boys is, we've already worked out in part B, 2/5. So the total probability of this happening is going to be 2/5 times these later probabilities, or times 42 over 117. Which is 28 195ths. And again, you can leave it as a decimal if you want, but this is a much more accurate answer. Okay, question 14. We have sets being involved here. Our universal set are all positive integers less than 20, so 1 to 19. A is the set of x, where x is less than 12, not including 12, I'm noting here. And B is the set of x, where x is between 7 and 16, including 7, but not 16. So list the members of A and B. That intersection sign means A and B. So that's going to be, firstly, positive integers less than 20, and they're going to have to be less than 12, not including 12, and between 7 and 16, including 7. So that's going to be 7, 8, 9, 10, and 11. C is the set such that C is a subset of A, so that's all of the elements of C are also within A, so I'm thinking these are all numbers less than 12. And this symbol here means the number of things in C is 3, so I've got 3 elements in my set C. Given that all the members of C are even numbers, list the members of one possible set C. So they've just got to be less than 12 and even. So 2, 4, 6 would work, or you could have any 3 of 2, 4, 6, 8, 10. Yeah, but it has to be 3 elements, no more, no less. Question 15, show that the recurring decimal 0.254 with dots over the 54 mean we've got 54 recurring, equals this 14 over 55. So this is where I have to try and make 2 expressions in terms of x where the bit after the decimal point is the same. So I'm trying to make it this recurring bit. So first things first, if I times by 10, I'll have 2.5454. 54 going on forever. And if I think about this a little bit more, if I move the decimal 2 more places, then I'll get another recurrence of 54. So that's if I times by 10 again twice, or make it up to 1000x. So this will be 254.545454. Now, taking one away from the other gives me 990x. The decimals will cancel out, which is why I wanted them to be the same after the decimal point. And then 254 minus 2 is 252. So dividing both sides by 990, x is going to equal 252 over 990, which, if I simplify, is 14 over 55. The first 5 terms of an arithmetic sequence are 7. So A is 7. As soon as I see arithmetic, I'm thinking A. N, we don't know yet. I haven't finished reading the question, but D is 3. It's going up in 3s, and it says find the sum of the first 100 terms. So N is 100. I can use that formula at the beginning of the paper. Where is it? Okay, here we go. So let's try and get back to where we were. Obviously, you can't copy and paste formulae from the start to the end, but it's quite convenient for me to be able to do that. So the sum to 100 is going to equal 100 n over 2 over 2, 2 times 7, 2a, plus n, 100, minus 1 times 3. Okay, I'm not going to mess around at all. Well, you can mess around if you want, actually, simplifying it a bit. This is going to be 50 times 14 plus 99 times 3. And that comes to, if we type that in on my calculator, 15 times brackets 14 plus 99 times 3, 15550, 15550. Will be 1 second. Okay. Question 17, similar shapes. Okay, so vase A has a height of 24, and vase B has a height of 36. Okay, now vase A has a surface area of 960. Work out the surface area of vase B. Now, a key thing here is not to get caught into the trap of 1D scale factors staying 1D, because we now have 2 dimensions in this question. We're looking at surface area. So my 1D scale factor is going to be 36 over 24, which which is 1.5, or 3 over 2. So my 2D scale factor is going to be this squared, or 9 over 4. So the surface area of B, if vase A has a surface area of 960, it's going to be 960 times 9 over 4, which is 2160. Now, if we're moving into volume, centimeters cubed, our scale factor is going to be 3 over 2 cubed, or 27 over 8. Okay, so the volume of B is going to be 27 over 8 times the volume of A. Now here it says the vase B has a volume of V, so let's replace B with that V, and therefore A is going to equal V divided by 27 over 8, or it's going to equal 8 over 27 V. Okay, question 18. We have a triangle. There's no right angles here, but we do have some sides. We're trying to work out this length. So we have 3 sides and an angle. This means I need to use the cosine rule. So this is where we say a squared equals b squared plus c squared minus 2bc cos a. Now here, a is this side, the angle even, and that means that little a is going to be the side directly opposite that angle. So a squared is going to equal, now b and c could be either of these two. So let's say a squared equals 17.8 squared plus 26.3 squared minus 2 times 17.8 times 26.3 times cos 36. Okay, and that comes down to be, let's type this in, 17.8 squared plus 26.3 squared minus 2 times 17.8 times 26.3 times cos 36. And that's 251.06 dot 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 dot, and then if I square root both sides, I have 15.844 dot 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 dot. It wants it to 3 significant figures, so this is 15.8 to 3SF. Right, question 19. We have a histogram. So whenever we've got a histogram, I like to introduce another column on the far side for frequency density. Now, frequency density is always frequency over class width. So here we have a frequency of 15 divided by a class width of 20. I'm just making a note of the class widths on the left-hand side here. The gap between the lower bound and upper bound. We get 0.75. 48 divided by 15 is 3.2. 21 divided by 5 is 4.2. And 16 divided by 10 is 1.6. So between 0 and 20, we want to go up to 0.75, which is about here. Oh, it's a bit high for me, that. Let's see if I can move it down at all. Okay. That's between 0 and 20. Forgive the slight inaccuracies of this. Between 20 and 35, we're going up to 3.2. Okay. That's going up to 35. And then down. Then over to 40, we're going up to 4.2. And then we're going up to 1.6, yeah, 1.6 for the last 10. Right, circle theorems. This question was not answered well. We need to work out the size of BCD. BCD is this angle here. Now, we have an angle of 71. I can use the alternate segment theorem here, but I need a triangle. So if this is a triangle with this length, I need to create a triangle out of it. So let's create a triangle over here. And the alternate segment theorem means that this angle is the same as this angle. Now we also have an isosceles triangle here. This is going to be 71. And therefore A is going to be 180 minus 71 minus 71, which is 38. And because opposite angles in a cyclic quadrilateral sum to 180, I know that C is going to be 180 minus 38, or 142. So I know what my final answer is. This is 142, but this is quite a big question. It's a 5 marker. I reckon there's going to be at least 2 marks there for an explanation, remembering and writing down those rules. So I can say, let's start off with D, B, A. That was the first thing I worked out, was 71. And my rule was angles in the same segment are equal. Okay, then I worked out that angle ADB was also 71 because base angles in an isosceles triangle are equal. And I then worked out that BAD was 180 minus these two, because angles in a triangle sum to 180. And then finally, I worked out BCD was 180 minus 38, which was 142, because opposite angles in a cyclic quadrilateral sum to 180. So 142. Okay, question 21. This is one of the trickiest ones on the paper, if not the trickiest one. So we know that we have a ratio of the radius of the cylinder, if we call this R, to the height of the cylinder is 1 to 3. So if this is R, this is going to be 3R. So the height of this cylinder, we can say, is 3R. And we're saying, given that the solid has a volume of 792 pi centimeters cubed, work out the height of the solid. Okay. So again, I'm going to need a formula for this hemisphere. Let's go back to the top. I wonder if they'll be able to help us out with a formula for here. Yes, we've got a volume of a sphere is 4/3 pi r cubed. So let's go back to this question now. Here we are. I'm just going to cheat again and paste this very handy formula. So if that is the volume of a sphere, a hemisphere, or half a sphere, is going to be a half times this. Okay, or we can see that actually the 2 and the 4 can cancel here to give you 2/3 pi r cubed. So that's going to be the volume of the hemisphere. The volume of the cylinder is going to be the area of the cross section times the height. So if I say the cylinder, is going to be pi r squared, that's going to be the base, times h, or actually pi r squared, what is the h? It's 3r. So this, if I simplify, is 3 pi r cubed. Therefore, my total volume is going to be 3 pi r cubed add 2/3 pi r cubed, and we're told that this total area is 792 pi centimeters squared. We're nearly there. We can divide both right-hand side and left-hand side by pi, so make it a bit more straightforward. So 3r cubed plus 2/3 r cubed equals 792. Now we've got a horrible denominator here, so let's just multiply everything through by 3. So 9r cubed plus 2r cubed equals, what's 792 times 3? 2,376. So 11r cubed is 2,376. I've just collected like terms on that left-hand side. And if I divide by 11, r cubed is 216. This is looking quite nice now. Let's try and find the cube root of this. R is 6. Now that's not my answer, it's asking me for the height of the solid, and the height of the solid is 3r. So h equals 3r, which is going to be 3 times 6, 18 centimeters. I reckon that's the hardest one on the paper, that. Okay, question 22. We've got the graph of sine x here. Now we have two transformations going on. We've got x plus 30, which is a shift to the left. Remember, it's not to the right of 30. And we've got a horizontal stretch of 2. So 1 is going to become 2, but it's also going to shift 30 to the left. 0 is going to stay 0, but shift 30 to the left. Okay, and all of these points are going to stretch. Whoops. Okay, down here, we're going to times by 2, so this will be down here and shift 30 to the left. Okay, and if I connect all of those points together, we should have, oh, there's one point there as well. We can use these values at exactly a half as well to help us plot this. So there we go. So that's going to go up, down, and we've got a point there, got a point here, and I think we've got another point there as well. So let's just keep this going. If you've got a graphical calculator, you're laughing. I'm going to just tweak this a little bit. I'm not quite happy with that end because it's got to carry on going. Okay, a little bit. Yeah, that will do. Okay, completing the square, the next one. So we need to half this middle term. That's going to go in the brackets, x minus 3 squared. Then I need to subtract that 3 squared, so minus 9. And I've still got this plus 10 at the end. So simplifying that last bit, x minus 3 squared minus 9 plus 10 plus 1. Now, what's going on if I need to describe how x squared maps onto this transformation? Well, remember, from above we know that y equals x minus 3 squared plus 1. Now this is a shift of 3 to the right, and this is a shift of 1 up. So we have a translation here. And if I want to use a vector, remember a vector is right and up. So this is 3 to the right and 1 up. Okay, question 23. We're nearly there. We've got a kite with coordinates at 10, 19 and 2, 7, let's say. And we are trying to, so this is the point B, this is the point D, and we've got A and C, I guess, somewhere here. Okay, oops. Something like that. Now, the key thing about a kite is that when you cross these over, it's perpendicular, and this is the midpoint of D and B. And it's asking us to find an equation of the line AC. So I need to find the midpoint, and I need to work out the gradient M of the line DB, and then I need to work out what the perpendicular gradient of that line is. And then I need to find it in the form of this. There's a lot to do here. Let's start off by working out the midpoint. So that's going to be the average x coordinate, so 10 add 2 divided by 2, and the average y coordinate, 19 plus 7 over 2. So 10 plus 2 is 12, 12 divided by 2 is 6, and 19 add 7 is 26, 26 divided by 2 is 13. So that's my midpoint. Now my gradient, again, is rise over run. So I've gone from 2 to 10, so that's 8 across. I've gone from 7 up to 19, so that's 12 up. Remember, so it's rise over run. So we've gone 12 up, and we've gone 8 across. And if we simplify that down, that's 3 over 2. Now my perpendicular gradient is when we find the reciprocal or flip the fraction, so 2 over 3, and times it by -1. Okay, so the gradient and its perpendicular gradient will always multiply to -1. And then we can use the formula y minus y1 equals mx minus x1. Or you could use y equals mx plus c to find your plus c. But the key thing is we've got a gradient of -2/3, and we know that it passes through this midpoint of 613. Okay, so y minus 13 equals -2/3 x minus 6. Now we want it in the form of py plus qx equals r, where p, q and r are all integers, so all whole numbers. So, and let's multiply through by this denominator first. So timesing 3 by 3, we have 3y minus 39 equals -2 x minus 6. I'm going to multiply these brackets out now that I've dealt with the multiplication of the denominator. So 3y minus 39, expanding the brackets, minus 2x, and plus 12. Okay, now I need it in the form of py plus qx. So I've already got py, I've got 3y, so it's 3y plus 2x. And if I take away 13, oh sorry, no, I need to add 39 to both sides. I'll get 51 on the right-hand side. So this is my answer, 3y plus 2x equals 51. Another tricky question. Finally, the last one. This is fairly straightforward for a final question. We have displacement in S. Now this should always be saying, oh, this might include dy by dx, a bit of differentiation. In this case, it's not dy by dx, it's ds by dt. So to find velocity, we differentiate once, and to find acceleration, we differentiate a second time. Okay, So velocity, I can work, so this is asking me to find the value of t at which the acceleration is 3 meters per second. So I'm thinking I'm going to have to differentiate twice. So v is going to be differentiating ds by dt. So that's times by your power. So t cubed becomes 3 times t, and then take away 1 from your power, t squared. 6t squared is going to become times by the power. 6 times 2 is 12, and take away 1 from the power, t to the power of 2 will just become t. And 5t will just leave a 5, and the minus 4 will disappear. Acceleration is going to be dv by dt. So we need to differentiate one more time. Times by the power, 3 times 2 is 6, take away 1 from the power is just t, and then minus 12t will just become minus 12. And we're told that the acceleration is 3. So a can be replaced by 3. So 3 equals 6t minus 12, and we're trying to find the value of t that works for this. So it's a simple equation to solve. Add 12 to both sides, 15 equals 6t. Divide both sides by 6, 15 over 6, or 2.5. And that's it, 100 marks.